Welcome to Algorush. We tend to treat databases like these magic black boxes, right? You send in a query, data magically pops back out. But have you ever stopped to wonder what is actually going on under the hood? Well, today we're going to demystify all of that. We're taking a journey deep inside the architecture of a database management system. So, seriously, what really happens when you type that simple select everything from users and hit enter? I can tell you it's not magic. It's actually a super organized multi-step process, all designed for maximum efficiency and reliability. So let's peel back the layers of that black box together. Okay, here's our game plan. We're basically going to follow a single query on its journey through the entire system. We'll kick things off with a big picture, then dive into the communication gateway. Check out the Smart Planner, see what the execution engine does, and finally get to the data vault itself. Let's get started. All right, first things first. A database management system, it's not just one giant, messy piece of code. Not at all. It's actually a beautifully engineered system made up of these distinct modular layers. Each one has a very specific job, and they all have to work together perfectly in a coordinated flow. So every single query, doesn't matter if it's a simple read or a really complex update, it has to pass through these four main layers. A great way to think about it is like an assembly line. The query comes in one end, a result pops out the other, and it gets processed and refined at each station along the way. So let's start at the very top. Okay, our first stop is what I like to call the front door. This is the communication hub for the entire system. It's the very first place your application makes contact with the database. You can see the transport layer sits right at the top of the stack. It's the single entry point for every request coming into the database. You can think of it as the system's receptionist and its switchboard operator all rolled into one. So this layer really has two big jobs. The first and most obvious one is accepting those incoming requests from your app. But, and this is crucial, in a distributed system, it's also responsible for talking to all the other database nodes in the cluster to coordinate everything. Right, so once your request is inside the building, it doesn't just get to run wild. Oh no, it gets sent straight to the central planning office. This is the real brains of the operation. This is where the strategy gets worked out. So after it gets through that initial entry point, the raw request is handed off from the transport layer down to the query processor. Time for some analysis. Okay, this layer is all about strategy. First, it parses your query, just to make sure the syntax is correct. Then it validates it. Does that table you ask for even exist? Do those columns? And here's where the magic really happens. The query optimizer steps in. This thing is amazing. It analyzes countless potential ways to get the data you want and then chooses what it thinks is the absolute fastest, most efficient plan to execute. So, with a brilliant plan now in hand, it's time to head down to the workshop floor. This is where that theoretical plan gets turned into actual, concrete action. And that optimized plan gets passed right down from the query processor to the execution engine. You can totally think of this as the handoff from the planners to the doers. This engine is the absolute workhorse of the database. It takes that step-by-step plan and it executes it. It's the part that carries out all the low-level operations, things like scanning an index, filtering rows, joining data. The key thing here is that it doesn't think or plan. It just follows the blueprint it was given, and it does it as efficiently as possible. And that brings us to our final stop. We've arrived at the very heart of the database. This is the secure vault, where all the data actually lives, breathes, and gets managed. See, the execution engine needs to read or write data, right? So it communicates what it needs to do to this final layer, the storage engine. And make no mistake, this is the foundation of the entire system. Everything else we've talked about sits on top of this one critical component. Now, the storage engine itself isn't just one single thing. It's way more complex than that. It's really an entire ecosystem of specialized managers, all working together in perfect harmony to store, retrieve, and protect your data, whether it's on disk or in memory. So inside this engine, you've got several key players doing their jobs. You have the transaction manager, which makes sure operations are all or nothing, ACID compliance. Then there's the lock manager, which is like a traffic cop, preventing different operations from crashing into each other. You've got access methods. These are the actual data structures, like B trees that organize all the data. The buffer manager is all about speed, caching frequently used data in memory. And finally, the recovery manager is the hero that rebuilds the system after a crash. And just to give you a taste of the kind of deep engineering decisions that happen down here, let's look at access methods for a second. A database might use something called a B tree. These are fantastic for workloads where you're doing lots of updates to existing records. Or it might use an LSM tree. These are optimized for a massive number of new writes. It's no surprise that systems like Cassandra, which are built to just ingest tons and tons of data, prefer LSM trees. This choice has a huge impact on performance. And this whole modular design is so powerful that many modern databases actually let you swap out the entire storage engine. It's wild. You see this in systems like MySQL or MongoDB, where you can choose from different engines, like InnoDB or Wired Tiger. Each one is optimized for a totally different task. This gives you, the developer, incredible power to tailor your database's storage to perfectly match what your application needs. So there you have it. What starts as just a simple string of text is first received by the transport layer, then it's turned into a super efficient plan by the query processor. That plan is acted on by the execution engine, and it's finally fulfilled by all that complex machinery inside the storage engine. When you look at it this way, it's really a masterpiece of modular engineering. So now that you've seen the whole blueprint, I have a question for you to think about. Where in this 4-layer journey do you think the biggest performance bottlenecks are hiding? Is it in the planning phase? Is it during the execution? Or is it all about the physical act of getting those bits off a disk?